Okay, so here's a look at the Cramer's Rule worksheet. Doesn't really look a whole lot different than what you saw in substitution and elimination method. Maybe a little less wackiness as you proceed down through the questions, although there are a few where I make you play around with the order, because remember, step one is to put them in order in terms of systems of equations. But other than that, there's not a whole lot of extra difficulty here that I can really throw at you. I think the matrices is going to be enough of a challenge just understanding that the first time through. So let's go ahead and take a look at a few questions together here. We'll start with question number 1. Question number 1 in the homework says 10x plus 7y equals 99 and negative x plus y equals 2. All right, now, as we saw in the notes many times throughout today, we do have standard form here. What we do not have, though, is we do not have numbers in front of either of the variables in the denominator. So that's one problem we need to solve right away. Of course, our magic fill-in is 1, and since that x on the left there was negative, it's actually going to end up being like negative 1. And now that we've solved that problem, we can go ahead and set up our fractions to find x and y with matrices in both locations, the numerator and the denominator, for both x and y. All right, let's start with the denominators as we always did, because that's our next step. That step says I'm going to fill in those denominators with the matrix of coefficients. That's the stuff that's in front of each variable. So in this question, that's 10 and 7 in the top row, and negative 1 and 1 in the bottom row. And again, these guys are always the same. Okay, next up, we're going to lift up the insides. So fill in the numerator on x. I'm going to lift up the right row there, 7 and 1. And on the y side, I'm going to lift up the left numbers there, the 10 and the negative 1. All right, not bad. Let's fill in the remaining spots now. Hopefully you remember from the notes presentation, those remaining spots fill in with the solution matrix. That's the stuff that's after the equal sign. So that's the 99 and the 2. That's what we're going to fill in the remaining spots here for x and y. And again, we do that in the exact same order it shows up in the question. So since 99 is on the top, 99 is going to stay on the top. All right, so now that we've done all that work, now we're going to go ahead and find some determinants. Again, the determinant says multiply down the main diagonal, multiply down the backwards diagonal, and then subtract those two results. Some big numbers here, but we're not going to let that phase us. X on the numerator, we've got 99 times 1, 99. 7 and 2 on the backwards diagonal, 14. And again, I'm subtracting those results. Go ahead and look at the denominators. 10 and 1 here, just 10. 7 and negative 1 here, which is negative 7. We know the denominator over here is the same for y on the right side there because it's the same matrix. So we'll just look at the numerator for the y side. We've got 10 and 2, which is 20, and 99 and negative 1, which is negative 99. All right, whole bunch of minus and negatives here. So let's fix all those minus negatives up into plus before we start taking through our operations here. So that's me fixing both denominators up here and the numerator on the y side. All right, so let's simplify here. 99 minus 14 at the top, that's 85 over a denominator of 17. Here we got 119 in the numerator and a denominator of 17. All right, so now we just got to do some dividing here and we'll be done. Obviously a little bit bigger numbers than maybe just the 4s and the 2s or the 3s and the 1s that we like, but we can do this. 85 divided by 17 on the right side there, or on the left side there rather, for x. 85 divided by 17, that's going to change into 5. So x is 5 here in my solution. And on the y side there, 119 divided by 7. 119 divided by 7 changes into 17. Again, big number. Oh, I'm sorry, 119 divided by 17 changes into 7. I'm sorry. Yes, 7. So y here is going to equal 7. So when I change x into 5 and y into 7 in both equations at the same time, the left side ends up equaling the right side. All right, let's try one more together. Question number 5 here. Question number 5. 10x plus 7y equals 49, and 10y minus x equals 70. Now, hopefully this bottom equation is setting off the alarm bells for you. The reason I say that is because look at the equation. Y is first. Can't have y first, you got to have x first. So we're going to have to flip that bottom equation. So I'm not going to touch that top equation. It's fine. But the bottom equation, I've got some work to do. I'm going to flip those around and make it say negative x plus 10y equals 70. And now I fixed that problem. But as you can see, that's created a slight new problem for me. Not one we certainly can't fix. We can. But there's no number here in front of x. So we're going to have to fill in our favorite placeholder there, which is 1. And that will end up being like negative 1 since there's a negative already in front of it. All right, and now it's perfect because they're in standard form. Both equations have x first, and then y, and then the equal sign, and then the number. So the next step tells me to go ahead and set up some matrices where I'm going to fill in some numbers. 2 fractions with matrices in both the numerator and the denominator, which as you can see I've done. Next step says fill in the denominator. Again, the denominator for the final time in this presentation is the stuff that's in front of the variables. So that's your 10, your 7, your negative 1, and your 10. And again, it goes in the exact same order it appears. So for instance, this is 10. Here is in the upper left corner. It's in the upper left corner of the matrix. 7 is in the upper right corner of what I highlighted, so it's in the upper right of the matrix. All right, next step says fill in the insides of the numerators by just lifting information up. So 7 and 10 and negative 1 get lifted up. And then the remaining spots for the left side on x and the right side on y fill in with the solution matrix. Going to be some big numbers here, but that's the stuff that's after the equal sign, the numbers I haven't touched yet, the 49 and the 70. And now we're ready to start finding those determinants. Again, multiply down the main diagonal, then multiply down the backwards diagonal, and subtract the 2. So if we start with x here, I got 49 times 10, 490. That's 7 times 70. Well, that's great. That's also 490. Let's go down to the denominator. 10 times 10, 100. 7 times negative 1. Negative 7. Denominator over here is the same. Numerator over here, we got 10 times 70, 700. 49 and negative 1 is negative 49. Now, as you can see, we've got some minus and negatives here, so we'll fix those up and change those into plus. And from there, we can go into solving. Now, this one's nice because, as you saw, it went to 490 minus 490, which is 0. Of course, 0 divided by anything, in this case 107, is going to give me 0. So x in my solution set here is going to be 0. And as far as y goes here, y is going to change into 749 over 107. And that's going to end up meaning that y equals 7 here. So we've got a solution of 0, 7. At 0, 7, the left side of both equations equals the right side in both, or if we graph these, that would be the point at which these two graphs would end up overlapping. Even with these big numbers, they cross over each other at 0, 7.